All right, here we go with some more U substitution. In 31, I do see a pretty obvious choice for U. That's just going to be the stuff that's up there in the exponent. That's pretty typical. E to the stuff, e to the stoof, e to the U, and then du. Oh, that's kind of weird. I don't know where that x went. It should be here. There we go. And then we get cosine of x dx, which is perfect. Look at that. Love it. All right, so that means we have the integral of e to the u and du. And you cannot get much simpler than that. E to the u plus c, which is e to the sine of x plus c. Final answer. All right, next up, 32. So I do see some stuff up here in the exponent. So I do feel like that would be my u choice. Let's check it out. U equals x to the fourth. Du equals 4x to the third dx. Then we can transform that into a 1/4 du equals x to the third dx. And that's really helpful because now my x to the third dx, which is this mess, gets replaced by 1/4 du. And then my x to the fourth up here, that'll change to u. And we're going to have a really simple integral here. It looks like this, 1/4 du out back, that's this business. And then we have just e to the u. So that turns into 1/4 e to the u plus c. And then we'll just change our u back to x to the fourth. Now, you really don't need to do all this work. If you see in the beginning, looking at the original integrand right here, and you see that e to the stuff, if its derivative is basically sitting out front, with the exception of the coefficient, just go write e to the stuff, e to the x to the fourth, and then figure out what would you need, what coefficient out front to counteract the fact that there's no number out front. So a 4 would have come into the play, but we cancel it with a 1/4. So hopefully that's something you can start seeing and doing a little bit faster. All right, next one. Number 32, I'm seeing that right here. In fact, I'm going to go for it. I'm just going to go write my answer. I think it's this. All right, and if I were to check my work, let's see, I'm going to go ahead and box this up. I feel like that's my answer. If I check my work, I get e to the negative 2x cubed times the derivative of negative 2x cubed, which is negative 6x squared. And all I really wanted was an x squared, so I better multiply by a negative 1/6. So we need to have a negative 1/6 out front. All right, so if you can do it that way, I would love to see you do it that way. The alternate route is, or u equals negative 2x cubed, yada, yada, yada. All right, let's move on to 35. All right, I think we've already done this one. Maybe you don't remember it. The bottom looks to me like some inverse tangent business if I rewrite it like so. So now I'm seeing u equals e to the x, and not because I want to replace this e to the x on top, it's because I want to get rid of this e to the x on the bottom. Because check out what du is, it's e to the x dx. So let's be careful here. So the e to the x dx, that's the top right there. So that's simply du. And then the e to the x inside here, that's going to be our u. All right, let's go do that. So we'll get e to the x dx is simply du on top, and the bottom is just 1 plus u squared. And that turns into inverse tangent of u plus c. Always go from u's to u's, and then once you're done finding the antiderivative, then you can switch it back and go put your e to the x stuff back in there. So there is number 35. All right, 36 coming up. Another one that we may have seen already, or it was similar. This looks familiar to me. I'm seeing that t to the fourth plus 1, and I want to rewrite that. I'm going to write it as 1 plus just to get it familiar. It looks kind of like that inverse tangent that we've seen so many times. So there we go, 1 plus t squared squared. So u should be t squared, and then du is 2t dt. So then we'll change that by moving the 2 over since we don't have a 2 up here. You could, of course, make a 2 up there. If you put a 2 up here, then you could put a 1/2 out front. But I'm not going that route this time. So, but you're welcome to do it that way. So my new integral, let's see, t dt becomes 1/2 du, and the bottom is simply 1 plus u squared. Again, can't get much simpler than this. 1/2 inverse tangent of u plus c. Change your u back to the t squared. And I believe we are done with that one. All right, so that's it for 36. All right, continuing on to 37. Let's see, I already rewrote our 5 over x as 5x to the negative 1, and I thought that would be a good choice for u, and you'll see why in just a second. I believe we did one like this a little bit earlier in this section. So I see that negative 5. I don't have a negative 5 here, but I do have an x to the negative 2 dx. That's sitting right here. I'm just going to rewrite by dividing both sides by the negative 5. And then I'm going to write the dx over the x squared so it feels a little more familiar. So these guys, that's this mess. Oops, and I forgot the du on this side. Let me throw that du back in there. Okay, and then let's see, up top, this 5x to the negative 1, that's our u. All right, let's see how that looks then. So we've got, let's see, sine of u, and then the dx over x squared is the negative 1/5 du, and this really turns out nice. We do need a negative cosine of u, right, because the derivative of cosine is a negative sine, but we have to cancel that negative because it's all positive over here. So this turns into positive 1/5 cosine of the stuff, which would be 5 over the x, and then plus c. I just want to double check my work on that. That looks pretty good. And don't forget, you can always check your own work by taking a derivative of your answer. All right, this next one here might be tempting to try to get rid of the secant squared, but remember, we know the integral of secant squared of x is just going to be tangent of x plus c. So I'm seeing u equals rad x, or x to the 1/2 is a really great choice for our u, because look at this beautiful derivative that shows up. I'll move the 1/2 over to the left because I don't have a 1/2 out front over here next to the integral sign, and then I do have a dx on top and a square root of x on the bottom, which is perfect when you look back over here. So that matches perfectly, so that'll be our 2 du. And then of course we've got the square root of x, which is just going to be a u. And it's okay that we don't have the secant squared rewritten. I'm good with the secant squared of the stuff, which is just u. And then remember the dx over root x, that's going to be a 2 du. And from there, this is really easy if you know your antiderivative rules for trig. So we get 2 tangent of the square root of x and plus c. And that would be it for number 38. All right, 39 and 40, very similar to each other. So the first step I would pull on this number 39 is I would move this 4 right here, and I would go put it here instead. And that tells me what a good choice for u would be. It's the stuff that's inside the parentheses, of course. So the derivative of cosine was negative. We're going to have a 3 from the chain rule. The derivative of cosine is sine of the stuff. So derivative of cosine is negative sine of the stuff. Don't change the stuff, of course. Times the derivative of the stuff, which would be just a 3. And then stick a dt on it. Now we got a negative out front. We did not have a negative up here, so we'll make that a negative du. So there's a 3 sine 3t dt. Oh, I just realized I probably should have taken that 3 over to the left. So let's do that. So that should have been a negative 1/3. Right? Divide both sides by negative 3, you get a negative 1/3 du, and then you got a really nice sine of 3t dt, which is sitting right out here. And then, of course, you got your cosine of 3t, which is your u. All right, I think it's time we can go rewrite our integral. Let's see here. So the highlighted pink stuff is going to be u to the 4th, And then the highlighted yellow stuff would be negative 1/3 du. All right, raising the power, we're going to get a 1/5 u to the 5th plus c. That turns into negative 1/15 stuff, which is cosine of 3t to the 5th plus c. Great final answer right there. If you wanted to let that power of 5 migrate back in, you could put it right here. And there you go. Negative 1/15 cosine to the 5th of 3t plus c. All right, next up, 40. Similar question. I already rewrote it. So u is going to be the sine of the 2t. I'm going to speed up a little bit here. Derivative of sine is cosine of the stuff. Don't change the stuff. You never change the stuff. Derivative of the stuff would be a 2. We don't have a 2, so we'll sneak the 2 over to the other side. 1/2 du equals cosine of 2t dt. Highlighting once again, that matches this. And then, oops, and that would be replaced with 1/2 du. And then the sine of 2t, well, that'll be replaced with the u. So here we go. New integral, 1/2 u to the 5th du. That looks kind of like a 6, so let's redo that one. U to the 5th, there we go. And we'll get 1/2 times 1/6 u to the 6th plus c, which of course is 1/12 stuff to the 6th plus c. And we get to throw the sine of 2t back in there. So final answer, 1/12 sine to the 6th power of 2t plus c. All right, got a couple more here, 41 and 42. I believe my u is going to be this x squared right here, because I see the derivative of it sitting right here out front, sort of. We haven't pulled this trick in a while. Let me sneak in. Let's go up here and say, hey, do you have a 2x? The answer is no, but now it's a yes. Put the 2 there, but put a 1/2 out front to counteract it. And then we can say, yes, we do have a 2x dx. That'll be replaced by du. And then let's see, the x squared here will be replaced by u. Okay, so rewriting our integral. The 1/2 doesn't go anywhere. The 2x dx is simply a du out back. And then we have a secant squared of u. And that is our good old tangent of u plus c. Change the u back to an x squared. And we are done with number 41. All right, 42 coming up. At first glance, I was thinking maybe inverse tangent because I see a 1 plus stuff to the 4th, but it's not just the stuff to the 4th. The whole two-term expression is taken to the 4th. So instead, I'm going to go with a good u choice, which would be the inside of the parentheses. And the derivative of that is kind of sitting on the top. It's not perfect. It's not perfect. I'm not going to lie and say it is, but the derivative of the 1 goes away. The 2 stays out front. The derivative of sine is cosine of the stuff. Never change the stuff. Times the derivative of that stuff, which is a 4. So we now have an 8 cosine 4 theta d theta. And just to do what we did on the last problem, I'm going to sneak that 8. So this 8 right here, I'm going to sneak that 8 out front. Let's see what's the right color for that. It's the green here. So I'm going to sneak an 8 here, but you have to do a 1/8 to counteract it. Remember, you're changing the appearance of the integral to make it easier for yourself, because now you've got exactly 8 cosine 4 theta d theta. So that's perfection right there. But to do that, you had to put a 1/8 out front. And then, of course, you got the inside stuff, the 1 plus 2 sine 4 theta. That'll be your u. Okay, let's rewrite. So we've got the 1/8 out front. All of the top, 8 cosine 4 theta d theta, all that is a du. The bottom is simply u to the 4th. So we bring that u to the 4th up before we go find the antiderivative. So next, we'll end up with, let's see, negative 1/3. Make sure that's a multiplication in between there, because you're going to have a new power of negative 3, because you always add 1 when you take the antiderivative, and then plus c. So negative 1/24 stuff to the negative 3 plus c. And our stuff, of course, was the weird 1 plus 2 sine of 4 theta. And you can leave your answer like that. You really don't need to go rewriting it. If you wanted to rewrite it,